question 9 is a very standard project scheduling or activity networks question. So we have a scheduling network here, information about the activities, edges show activities, and the letters don't tell you which ones happen after the other. So for example, just because it goes A, B, that doesn't mean A happens, then B happens. It's the usual stuff. The nodes just show points in the project. The source is the start, the sink is the end. Okay. Explains the significance of the edges represented by dotted lines. So there's a lot you could say about this. I'm going to show you everything that I would say about it. Obviously, the marking scheme doesn't have that much, but I'm just going to show you everything because you want to write as much as possible just in case, because there's no indication as to how much detail you need to include. So I guess first thing you could say is they are called dummy activities. Then explain what that is. They show the order in which, what are they called? They're called actions, aren't they? Or no, they're called activities. In which activities happen, but aren't activities themselves. So basically, what they do is they're like activities that take no time to complete. And then I always like to give it an example, just because it's just nice to add extra stuff into it. So what you could say is the first dummy activity. The first dummy indicates. So the first one, obviously referring to this one here, indicates that G, H, and I depend on C as well as B. Because obviously this is basically saying that all the requirements for this node also apply for this node here. That's basically what it's saying. You could use similar wording. It doesn't really matter. You could say that they show which activities helps show which activities depend on others. It kind of doesn't matter, whatever way you want to say it, but that's how I'd say it. Then another kind of standard exam question for part 2, they give us this precedence network, or table, sorry, to fill out. So it's complete the table below by listing which activities it depends on. That is, for any activity X, which is an element of all of these activities, write the smallest list of other activities which you need to complete before X can begin. And they give you space to show work. You don't need that, really. So let's just start. You just need to position this correctly. Make this a little smaller, maybe. There we go. Okay, so first of all, A, B, and C come from the source, so they don't depend on anything. You can just put a little hyphen or a little dash to show that. D, as we can see, depends on A, because basically D comes out of this node, and in order to get to this node, you have to go through A. It's kind of the thought process behind it. E, also it comes out of that same node, so it also depends on A. I don't know why I wrote D here. I mean, it depends on A. E also depends on A for the same reason. It's coming out of the same node. F depends on C, because C goes into this node, and then F comes out of that node. So this F depends on C. Note that the dummy doesn't affect this. The dummy is telling us stuff that this node this node is a requirement for this node, but it doesn't actually affect this node. The arrow is kind of going into this node, so this is the node it affects, because this is a digraph. For G, this is where it's going to happen. So first of all, we have E and B. So G depends on this node here. And in order to get to this node, we have E has to be done and B have to be done. So E and B have to be done. But as well as that, this dummy here tells us that this node is also a requirement for this node. Therefore, since C is a requirement for this node, it's also a requirement for this node. So we have E, B, and C. H comes out of that same node, so it's the exact same. E, B, and C. And I also comes out of that same node, so it's also E, B, and C. And now we're done with all those, so I'll rub this out. For J, J is just coming out of this node here, and in order to reach this node, D and G have to be done. So we'll write D and G. For K, it comes out of that same node, so it's the same, D and G. Then we have L. L is here, so what has to be done to get to this node? We have K and H. K and H. And then this dummy says that this node is also a requirement, and for this node we have I and F going into it. So we also have I and F. Finally, for M, we just have coming out of this node. What's the requirements for this node? It's just I and F are the only two edges going into that node. Therefore, they're the only requirements. Then we're told to complete basically the early and late times. So early time is going to be the upper box, late time is the lower box. And they give you work, but it says if necessary. It's not necessary for us. So basically, remember, the early time is the earliest kind of point at which we could complete this activity, and the late time is the latest point we could start this activity without delaying everything else. So at the start, obviously, the earliest we could start it is 0, and the latest we can start it without delaying anything is also 0. Then we fill in all the early times, then we'll work backwards after. So the earliest point time by which we could reach this point in the project is after 3 days, because obviously A has to be done to get there, and it'll take 3 days. We won't do this one yet because it depends on D and it depends on G, so can't be sure about that. Instead, we can look at this one. So we have E and B. So even though B will take 2 days, actually we can't even do that one because we need to do this one first as well. Obviously, to get to this one, we'll need 5 days for that C to be done. Now we can look at this one. So we'll have 2 days for B to get there, but we won't be here after 2 days because we also need E to be done. And E will be done after 4 plus 3, 7 days, and C will be done after 5 days. So that means the earliest point we could reach this is after 7 days because E has to be done, and B and C, and E will take 7 days. So 7 days is the earliest we could get there. Now we can do this one up here. So we'd have 8 days for D to happen. So we'd have 8... or we'd have 9 days for G, so obviously it's going to take 9 days minimum to get there, because even if D is done after 8 days, we have to wait until G is done as well, so that'll take 7 plus 2, 9 days. We can go down here now, I suppose, because these ones depend on this. So here we have 5 plus 4, 9 it'll take 9 days for F to be done. Here it'll take 13 for I to be done, but both F and I have to be done. Therefore, the earliest we could get there is 13, since I also has to be done. For this one here, we have K will take 12, we have H will take 10, and I, or at this point, is just 13, so we just have the 13 here as well. So since this 13 is a requirement, it'll obviously, the earliest we could get here is 13, since this also has to be done. And then finally, the sync node, I'm just going to rub out all these working numbers. We have 11 here, we have 15 here, and we have 16 here. Of course, the earliest we could get here then is 16, since all 3 of those have to be met. So basically, the project can be done in the quickest at 16 days, and we don't want to delay it for our late times, so we're going to also write 16 for our late times and work back. So it's easy to do the ones that only have 1 arrow going back to them, so we're kind of working backwards. There's only 1 arrow going here. So obviously, in order to get to this point, the absolute latest we could be at this stage is 13. If we were here any later than 13 days, well, that would mean that M would take, let's say if we were here at 14 days, M would take 3, we'd get to 17. That's not going to be right. So that's why 13 days is the late time there. For this node here, it's obviously going to be 14 because the only one coming out is L. So think about it, if we got to here after day 14, an extra 2, we still get to 16 and it's all good. But if we were to get here, for example, for 15 days, then plus the 2 gives us 17, we end up delaying the project. But if we get here in 13 days, it only takes 2, we have 15, we have 1 day to spare. So we can delay this by 1 day up to 14. Now we can look at this one, since we have the 2 hours going into it. So here we have, if we were to look at just J, if we started J on day 14, then we could have the 2 and we get here on time, all good, all dandy. Here, the absolute, well, since we can reach here after 14 days, we could reach here technically after, if we started here at 11 days, then 11 plus 3 brings us up to 14, and that requirement is in fact met. But the late time is 11, that means. Because if it was 14, then we'd have 14 plus this 3, which is 17, plus the 2. It ends up getting delayed. So we have to put the 11 there. Even though this one is 14, we have to take into account that this also has to be met. So we put 11 in there. Let's look at we'll look at this one next, I suppose, because this is the one that we have all the information for the edges going into it. So here, we could do 9. If we started at 9 days, we'd be good, because then we have 9 plus 2 brings us to 11. That's all good. Here we could start at 11 days, because 11 plus 3 brings us up to 14, and then that satisfies. Here we have 13 and 6, we have 7. So we have to be here by 7 days. at the latest, because if it was any later, then this would be delayed, and then we have a problem. So yep, 7's the answer there. Get rid of the rest of the workings. We can look here now. So here, if we started on day 3, that'll be all fine and dandy, because 3 and 4, that's all good. But we also have this. If we started on day 6, we'd be good here, because if we did day 6, this takes 5 days, we get here to 11, that's all good. But we have to take into account that we will have to get E done on time, and for that to happen, we have to be on day 3. So day 3 is our answer there. And finally, here we have F. So F, obviously the earliest, if we get here for day 7, that's all good, it satisfies this one. And here we can get here on day 9, and that satisfies this one. So the early time for this is 7, because if we got to 9 here, then we'd be 9 here, and that would delay the project, so we can't do that. Therefore, it is 7. So yep, that's our early and late times done. Write down the critical path is part 4. So the critical path is just the path along which we can't delay anything, so we just follow them. The critical path would be doing A. Oops, I'm still on black. We'd go A, then E, and then we'd go I, then just M. So we're just following all of those ones that have the same number on the top and bottom, which basically means they can't be delayed at all. In part 5, it says the minimum time needed to complete the project. Well, we can see it's 16 here. I think I was saying days earlier, but I didn't actually check. Up here, it says, it should say information about the relationships. Okay, here it says the time in hours. So this is 16 hours is our answer. So it takes 16 hours to complete the project. As you can see here, we can get to the end by 16. If activity D takes 7 hours instead of 5, what effect will this have on the critical paths and the time to complete? Well, let's have a look. Activity D is this one. So if this was 7 is basically what we're saying. Well, what we can say, so if this is 7, think about it. Basically, if we start here at the absolute latest, which is 3, then 3 plus 7 is 10. So we still get here on time. We're not delaying anything, because remember, we can delay this. Oops. We can delay this up until 11, and that won't have any effect on the final time. So if we take 7 days to do this, we'll only get here in 10, so we're still on time. So it actually has no effect on either. It has no effect on either, because the critical path obviously isn't affected. This doesn't make a new critical path or anything, and it also doesn't delay the project at all, so it doesn't change the time to complete it. The reason we can say is because the late time is here, it's 3. If D took 7 hours, it would reach the next node after 10 hours, which is less than the late time of that node, which is 11 hours. In the final part 7, it says if J takes 7 hours instead of 2 hours, what effect will this have on the critical paths and the time taken? So let's have a look at J. So here we have J. If this was 7 hours, okay, so we might have, oh no, we won't have a problem here. If J was 7 hours, then if we think 11 plus 7 brings us up to 18, 18 would delay the project. But since we could technically reach this point after 9 hours, well then that means that if we do 9 plus 7, we can get here in 16. So the only difference it makes is we can't delay this until 11 anymore, because 11 plus 7 obviously going to be bigger than 16. So that means that the late time actually changes to 9. And that means that the early time and the late time are going to be the same. That means that this activity can't be delayed anymore, which means that that's going to become a critical activity. So what will this effect will this have on a critical path? So first of all, J will become a critical activity. Critical activity. As it will have to start on day 9 if the project is to be completed. Is to be completed on time. Bit of a rhyme there. And then, so that's basically what happens. So that's what will happen, you actually didn't have to say this. I guess this is kind of like our explanation. But now to answer the question, what effect will it have on the critical paths? So let's have a look. Well, if this is 9 and 9, we actually have a new critical path. I'm just going to write it in for now. I'll replace this with 9. So you can see our original critical path was here, 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 and here. We have a new one now, though. We have A, E, G, J. So we have a new critical path. So there would be another critical path. Because, of course, the other critical path, it hasn't changed. The other critical path is still there. The A, E, I, M, that's still there. But we also have a new one, A, E, G, J. A, E, G, J. What effect would it have on the time taken to complete the project? Well, we said it can still be completed on time because we could just change the late time of this and it'll all be good. It'll all be still completed on time. So we can say there will be no effect on time to complete project. I'm just kind of, obviously you'd probably want to write full sentences, but writing's kind of slow and I'm speaking as well. So yeah.